Hello everyone, welcome to ACE Engineering Academy and ACE Online. This is Ramesh Pabba, faculty at ACE Engineering Academy. In this session, we are going to have ISRO PYQs from the subject called Basic Electrical Engineering. BW subject I am taking, PYQs as well as some practice questions. Both questions I am going to take. Here is the first question. Which loss in a transformer varies significantly with the load? Nothing but with respect to the load, the losses must be varied. So therefore simply called as variable losses. Generally, as the load is varied, copper losses will be varied. Copper losses are also called as I square R losses we say. So therefore, right, the load is varied, automatically copper losses will be varied. I square R losses. So answer here is copper loss. And in the transformer, one more other loss is also there. Constant loss, hysteresis and eddy current losses, combinedly called as core loss. This core loss is constant loss. So therefore, this is the correct answer, okay. But other options also I am explaining. Hysteresis loss, eddy current loss are called as core losses, or core loss are called as constant losses. But he is asking variable loss. So answer is copper loss. Right? Next question. The desirable properties of a transformer core material. Nothing but whatever the core material we are using, that material should have dash properties. Let us see one by one. Low permeability, no, it should have high permeability, but answer is low. Here, wrong here. High permeability, correct only, but high hysteresis loss, no. And high permeability, yes, low hysteresis loss, correct. But here, low permeability, wrong. That's why the first elimination must be low permeability and low permeability eliminated. And then high permeability, both options are there. Then go through this. High hysteresis loss, always we expect less hysteresis loss. That's why answer must be option C. Right? Next question. The eddy current loss is proportional to the eddy current loss is proportional to dash. Generally, the eddy current loss is proportional to square of the frequency we say. If nothing is given, we need to consider that as maximum flux density is a constant. As the maximum flux density is a constant, the eddy current loss is directly proportional to square of the frequency we say. Otherwise, normally we say WE is proportional to B max square into F square, generally we say. If no condition is given, generally B max is assumed to be constant in general. That's why WE, eddy current loss, is proportional to frequency square. So therefore, here this B max is a constant, that is a technical assumption. So based on that, what is the answer? Frequency, no. Square of the frequency, correct. But here cube of the frequency, square root of frequency, all are wrong. So direct answer is eddy current loss is proportional to square of the frequency. Right? Next question. Here, this is the question from DC missions. The armature resistance of a 200 volt DC mission. He has not given it as a generator or it as a motor, simply it is a DC mission he has given. Has 0.5 ohm. If the full load armature current is 50 ampere, what will be the induced EMF? What he is asking? Induced EMF. When the machine acts as generator means we are supposed to find out EG, and as a motor means we are supposed to find out EB. Simple logic. EG as well as EB. Now let us write the data first. V is given as 200 volts. V is given as 200 volts. And the machine has armature resistance RA as 0.5 ohm. The full load armature current. So therefore, IA is equal to 50 amperes. Now, what is asking? Generated EMF. Now I am taking the first one. Generated EMF EG is equal to V plus IA into RA. V plus IA RA. This is a formula. If you are able to recollect the formula, answer is very, very simple. What is it? V is 200 plus IA 50, RA is 0.5, right? You are simplifying means 200 plus 25. Therefore, value will be 225 volt. Value is 225 volt. Which one? Generating voltage. Now check it here. In all these options, luckily 230, 210, 202.5. So answer is 225. Only one option is there. Go for it. In that way, you need to save the time. Suppose if more than one option is having with 225, calculate the other thing. Otherwise, simply eliminate the options and answer is this. But for practice purpose, I am taking second one. What is EB? What is EB? EB value is V minus IA into RA. EB is equal to V minus IA RA. V is 200 minus IA is 50, RA is 0.5. So therefore 200 minus 25. Therefore here 175 volts. 175 volts. So this is the answer. Verify here. Yes, 225, 175 matching. So option will be C. Right? Next question. Consider the following statements. Right? Some statements are given. The armature torque means simply TA he is asking, or simply T we can say. In a DC motor is a function of. First of all, the torque formula or torque is a function of phi into Ia we can say. The torque is proportional to phi into Ia. What is a phi? Field flux. What is Ia? Armature current. The moment you are recollecting this formula, thing is over. Now check it here. Function of phi, field flux, correct? And armature current, correct? But here speed, no. And then damping also, no. Among the corresponding options, which are there, 1, 2, correct. So here, 1, 2, 3, 4. 4 is not there, so 4 wrong. 3 and 4 only, right? 4 wrong. Here 4 only wrong. So among the available options, what is it? Simply 1 and 2. So therefore, among the given options, what is it? 1 and 2 is given. But in the other options, 4 is there, damping, 4 is there, 4 is there. Blindly you can eliminate it because in this damping is not the function. So simply damping is wrong. So among the available 1 and 2, yes, these two are correct, we can say. Right? Next one. Match the list 1, list 2. For a practice purpose, all these questions I am taking. What is it, sir? In the list 1, DC machines quantity is given. List 1, DC machine quantity is given. List 2, relation is given. And correspondingly, we need to match it. Now, so developed power, torque, generated EMF and speed. So corresponding options are given. So before going to that, let me write the formula here. Developed power. What is the power developed? Induced voltage or developed voltage we can say into Ia. So nothing but P is equal to EB into Ia. What is the torque? Torque is equal to torque proportional to we can say simply phi into Ia. Phi into Ia. And generated EMF. Generated EMF EG is equal to phi ZNP by 60A is a general formula. In this, which are constant? Here, Z is constant, number of conductors, number of poles constant, 60 is constant, A is also constant. So therefore, what is that? EG is proportional to phi N. And what is speed? From this only what we can write? N proportional to E by phi. So this is one, and these 4 are asked. Can you check it? Developed power. What is that? EB into Ia. Where is it? Developed power. EB into Ia. And then torque phi into Ia. The torque is phi into Ia. Where is that? Yes, phi into Ia. And then generated EMF. What is generated EMF? Phi into N. So generated EMF is phi into N or N phi. And finally, speed is E by phi, or he has given, yes, EB by phi. Right? If you are able to recollect the formula like this, yes, simply we can match the corresponding parameters. Right? Next question. A machine has maximum efficiency. Maximum efficiency when? Simple logic. The efficiency is maximum. Efficiency is maximum means what should be the condition we require? The condition will be variable loss. Variable loss is equal to constant loss. If this condition is being satisfied, what we can say? The efficiency will be maximum. That only he is asking. The DC machine has maximum efficiency when? So direct option, variable loss is equal to constant loss is the answer. But very important point, variable loss root of constant loss wrong. Variable loss constant loss square is also wrong. But people general doubt is, sir, constant loss equal to variable loss equal to constant, both are same, sir? No, both are not same. Variable loss equal to constant loss means we are varying the variable losses and making equal to constant loss. That is correct. But if you are writing like this, constant losses are made equal to variable losses, can you change the constant losses? No, that's why don't choose this. Definitely variable loss equal to constant loss is the answer. Nothing but variable loss are made equal to constant loss. That is the point. But here constant loss are made equal to variable. Acceptable? No way. That's why answer is variable loss equal to constant loss. In the different competitive examinations, both options will be there. Choose wisely. Right? Next question. A transformer has 2% resistance, 5% reactance. And what they are asking, voltage regulation at full load at 0.8 power factor lagging. What is 0.8 power factor? Cos phi is equal to 0.8 and sin phi is equal to, cos phi is 0.8 means sin phi is equal to 0.6. First get this. And which load he is asking? Lagging load. So therefore, let's have the solution here. Percentage voltage regulation is equal to percentage R into cos phi, percentage X into sin phi. As the load is lagging, the sign will be plus here. If the load is leading, minus will be there. Now, what is resistance percentage? 2% into 0.8. 2% into 0.8 plus what is reactance? 5% into 0.6. So what will be there here? This is 1.6% plus this is 3%. So answer will be 4.6%. What is the formula? Percentage or cos phi, plus symbol is there for lagging load, minus symbol is there for leading load. But he is asking lagging load. So what is the answer? 4.6%. Yes, 4.6%. Right? Next question. In an auto transformer. So what do you mean by auto transformer? First of all, auto transformer in the simple way called as one winding transformer. Auto transformer is nothing but one winding transformer. In this one winding transformer, the same winding is acting as primary and secondary, we can say. So that's why what we can say, the power is transferred in both modes, conductively as well as inductively. But in the normal two winding transformer, power is transferred only inductively. Why? Two coils are electrically separated, only magnetically linked. But in auto transformer, one winding is only acting as primary, some part of that is acting as secondary, we can say. So that's why only one winding will be there. Therefore, the power is transferred both conduction and induction processes. So conduction will be there and induction. Therefore, conductively and inductively coupled, we can say. So answer is both. Right? Next one. A transformer may have negative. A transformer may have negative voltage regulation. A transformer may have negative voltage regulation for dash power factors. So in order to get negative, first of all, try to understand. Let us understand this one. What is the voltage regulation formula? Percentage R cos phi plus percentage X sin phi. Do we have any chance of getting negative sign of voltage regulation here? No. Why? Something plus something. So therefore, there is no question of what is that negative value. Suppose if you are having negative symbol here, there is a chance. Why? Small minus large. There is a chance. Now tell me, the negative is there. This entire value may be negative. Therefore, the negative voltage regulation is possible for which loads? Capacitive loads at some power factor values, correspondingly small value, large value. According to that, we can say yes, voltage regulation may be negative for some values of capacitive load. Check it here. Leading power factor, yes, leading capacitive for some value of power factor, correct? But here unity power factor means this will be 0, something plus 0, something minus 0, cannot be negative. Lagging but not 0 power factor. Lagging means plus will be there, something plus something, cannot be negative. And then only 0 power, not correct. So therefore automatically leading for some values of power factor. Right? Next one. When are eddy current losses? When are eddy current losses in a transformer reduced? Nothing but when do we have eddy current losses? Very, very less point. That is what the question. Laminations are thick. No. If laminations are thick, what is that? Eddy currents will be more, thereby eddy current losses will be more. Wrong. If the number of turns in primary winding is reduced, there is no relation with number of turns to that point. Number of turns, it is also wrong. Now finally, if laminations are thin, yes. If laminations are very thin, the circulating current will be less. What is the simple logic I am giving? Suppose this is the core. I am taking only lamination like this. More area is there, so more circulating current will be there. Suppose in the same core area, if I am making so many laminations like this, means laminations are very, very, very thin. For example, if laminations are very, very thin, what is this? The corresponding to this circulating current will be reduced. Circulating current means what? Eddy current. Therefore, eddy current is less. Therefore, eddy current losses will be less. So, I am writing IE is less. Comparatively here, IE is more. What is asking? Eddy current loss in a transformer reduced. Reduced means by making thin laminations. Thin lamination means we are simple way I am giving. We are providing very less area for circulating current. Therefore, the current strength is reduced. Therefore, eddy current loss will be reduced. That's why answer is laminations are thin. Right? Next one. A 2 kVA transformer, very, very important model. A 2 kVA transformer has iron loss of 150 watts and full load copper loss of 250 watts. Iron loss is 150 watts. Full load copper loss are given as 250 watts. Okay. The maximum efficiency. What is asking? Maximum efficiency. Already we have taken maximum efficiency. What is the condition? What is the condition? What is it? Variable loss must be equal to which loss? Constant loss. What is variable loss? Copper loss. Copper loss must be equal to which losses? Iron loss, we can say. Copper loss must be equal to iron loss. Okay. Now, so copper loss are given as 250. Iron loss are given as 150. What is asking? The maximum efficiency of the transformer would occur when the total loss is, Now, in the hurry mode, what we say? 250 plus 150, 400. Wrong option is there. Wrong answer is there in the option. And here my question is, this 250 watts value must be changed and equated to 150, or 150 value of parameter is varied and equated to 250, means which must be varied? Copper loss must be. That's why we need to vary this. We need to make it equal to 150. We need to make it equal to 150. That's why what we can write now simply, the total loss under max efficiency condition, copper losses are varied and equated to iron losses plus iron losses as it is. If writing like this, what does it mean? Copper loss value varied and equated to iron loss. So therefore, iron loss is how much? 150 plus 150. So answer here is 300 watts. So answer is 300 watts. Don't reverse it. What is that? 150 change, 150 change, 150 is varied and equated to 250 means 250 plus 250, 500. Wrong answer is there. If you are adding directly 400, wrong answer is there. That's why be clear. Variable losses must be varied and equated to constant. That's why copper losses must be varied, equated to iron. That is equal to simply 150 plus 150, 300 watts. Right? Next question. While performing the open circuit and short circuit tests, right? What is the corresponding condition? Simple logic. In the transformer, OC test is conducted. OC test is conducted by making which winding open? High voltage winding open. We open the high voltage winding, we conduct the test on LV side. And SC test, short circuit test, is conducted on which side? HV side, by shorting the LV side. That's why answer is directly this one. In OC test, HV is open and in SC test, LV is shorted. So what does it mean? HV is opening means on the other side, LV side, conducting the experiment. LV is shorted means on the other side, HV side, experiment is conducted. So therefore simply OC, HV open, SC, LV is shorted. Right? Next. Here, the losses in a transformer are, what are the losses? Copper loss, yes, it is there. Eddy current loss will be there. Hysteresis loss is also there. But what he is asking? The constant power loss of a transformer loss is given by, what is given here? All these three losses are there, okay. Because in the transformer, copper losses will be there. Eddy current losses will be there, hysteresis loss, all three losses. But what he is asking? Only constant losses. Sir, what are the constant losses? Copper losses, variable loss. Copper losses, variable loss. Now, eddy current and hysteresis losses, nothing but iron losses. Okay, iron loss is nothing but constant loss. Iron loss is nothing but constant loss, obviously. So therefore, what is that? Here only constant loss he is asking. So 1 only wrong, 1 and 2 only wrong, 2 and 3, yes, 2 and 3 correct. So these are correspondingly constant losses. That's why answer is very simple. While choosing the options, be careful. Okay, next one. Right. For an ideal transformer, the winding should have. Ideal transformer means losses should be present or losses should not be present. Losses should not be there. Simple logic. Now check it. Maximum resistance, wrong. If maximum resistance is there, losses will be more. Least resistance, no. Ideal means losses should not be there, but least resistance, not acceptable. Equal resistance on primary and secondary, wrong. Actually, resistance should not be. That's why no ohmic resistance. No ohmic resistance means simply no ohmic losses, we can say. Yes, ideal transformer, among the 4 options, which is suitable, no ohmic resistance on either side. Then only it is called as ideal transformer. Right? Next question. Right? Consider the corresponding very, very simple question. Consider the following number of turns. So N is given and length of the coil L is given. Area of cross section of the coil A. Permeability of the core simply mu. Right? Among this, what he is asking, on which of the above factor does inductance depend? On which factors the inductance depend? First of all, what is the inductance formula? Inductance formula is N square by reluctance. N square by reluctance. What is that? N square by reluctance is L by mu into A. L by mu into A. So therefore, N square into mu A by L. So this is what the self-inductance L formula. L depends on number of turns, correct? L depends on permeability, correct? L depends on area of cross section, correct? Inductance depends on length, correct? So therefore, the inductance depends on all the four. So therefore, answer will be this 1, 2, 3 and 4. Clear? Right. Next question. Here, in this mathematical notation, what can we write here? A mathematical expression for 50 Hz sinusoidal voltage. Peak value is 80 volt. Peak value is 80 volt. Nothing but what he is asking generally, V of t is equal to Vm sin omega t is a normal representation. Okay. Sir, what is omega? Omega is equal to 2 pi f. What is that? F50 is given. 2 into pi into 50. 2 into pi into 50. This is 314. Omega is simply 314. Here, this is 314. This is so simply 80, 50 wrong. But what is V maximum peak value? 80. But this is simply 50. So blindly answer is 80. That is a Vm. That is peak value. Sin omega t. Omega is 2 pi f. 2 pi f is 314. So answer is 80 sin 314 t. Right? Next question. Here the total flux at the end of a longer bar magnet is 500 microweber. Total flux means what? Initial flux, final flux, change in everything is done. So total flux is 500 microweber. 500 microweber. The end of the bar magnet is withdrawn through 1000 tons. Nothing but number of tons are 1000. In how much time? 1 by 10 seconds. 1 by 10 seconds. The EMF generated across the terminals of the coil. The EMF generated across the terminals. So what is the formula? Induced EMF E is equal to what we can write, right? N d phi by dt. N d phi by dt. Actually minus will be there, but options are not with minus, no issue. N d phi by dt. Number of tons are 1000. Number of tons are 1000. What is the total flux they have given? Simply 500 microfarad. 500 into 10 power minus 6 divided by how much time? 1 by 10. 1 by 10. Now 1, 2, 3, 4, 5, 6. So therefore, what is that? 5 into 10 power 6 into 10 power minus 6. So blindly 5 ohms. So this is the answer. Simply, you are able to recollect the formula, that is enough. N d phi by dt. Yes, 5 ohms. Right. So these are few PVQ questions, previous year questions, as well as some practice questions I have given. Prepare well. All the best.